All right, welcome to Peter's Parachutes by Matthew Yonan.
Remington Stab.
And I'm Brennan Steichen.
All right,
At Peter's Parachutes, we are trying to find the best possible material and shape to use to make great parachutes for our customers.
we will test these different materials by dropping them and tracking their movement to obtain their terminal velocity and force of air resistance acting on them, or drag.
We are looking for minimum terminal velocity and minimum air resistance to make sure our consumers are landing safely.
Here's our experimental setup. We had 4 different materials that we used. We used a coffee filter, a newspaper, paper plate, and paper towel. And we ran 4 different tests for each of them. We ran 3 trials for each material. And we have our weight of each material under each. And that was what our variable change was the material because we just dropped at the same height every time.
All right, so these are a few models for visualization. So we have a system schema for our setup in which the object is being interactive with the air. And the air is forcing air resistance onto the object, and the earth is pulling both down through the force of gravity. And then we also have our free body diagram here, where the object essentially is being pulled down by the earth, and at terminal velocity is also being pushed up by air resistance with the same force, same magnitude of force. All right, here's data.
Oh,
There we go.
to visualize the data for our objects, we chose to use a position graphs, velocity graphs, and then we did the magnitude velocity graphs. And as you can see, the Y's for the position graphs all constantly go down due to the object falling, while on the x-axis, they're more randomized due to the object swaying back and forth while falling.
And here's down to the numbers for data. We calculated air resistance for each object. So we converted our grams to kilograms and multiplied that by the force of the acceleration due to gravity, which is negative 9.8, and we got our air resistance numbers for all of our objects.
Yep, and then we also found our average velocity in our y direction. And because we dropped every object from 1.87 meters, we were able to keep that constant the whole time, and we just used the change in time to figure that out. And after we ranked the both air resistance and average velocity, we found that for air resistance, it was coffee filters less than paper towel, which was less than newspaper, with paper plate having the highest air resistance. And then average velocity, it was paper towels less than coffee filter, less than newspaper, with paper plate also again having the highest velocity.
And based on our previous findings, we found that the velocity is proportional to the force of air resistance. So in other words, as velocity increases, the force of air resistance will also increase. For our parachute, we decided to go with the paper towel due to it having the lowest average vertical velocity out of all the options. And then we tried our best to minimize error by dropping every object at the same height of 1.87 meters by holding them steady at the same position. Additionally, we did 3 trials for each object to minimize random errors. And to find our standard error of the average velocity, we did standard deviation divided by the square root of sample size. And we found the standard deviation to be 0.52 meters per second, while the sample size was 4. So we divided the two and found a standard error of 0.26 meters per second.
All right, thank you so much.
Thank you.